started. Okay, so first we are going to see flow over the thin flat plate. So here I have taken two cases. One is subsonic flow over the flat plate, here supersonic flow over the flat plate. Okay, so if you take subsonic flow over the flat plate, there will be a bound layer growth and you can get the pressure distribution like that, like almost similar to the aerofoil. Okay, well, the only difference between flat plate and the aerofoil is, so here the stalling angle will be more. This may be stalled at 15 degree and this may stall at 7 degree, 8 degree itself. Okay, because of this curved surface, the stalling angle is increasing. Other than that, for smaller angle, both may produce this type of pressure distribution. Okay, because here it will be more acceleration, so you will get more pressure difference, then it will be decreasing. Okay, this is how it will happen in the subsonic. But in the supersonic, if you take, so the flow has a very high kinetic energy, so the flow separation is negligible on the surface. So here if you see, you will get the constant pressure distribution. Okay, if the surface is flat, then you will get constant pressure distribution in the supersonic flow. Is that clear? In subsonic, you will get variable pressure distribution, but in the supersonic, if the surface is flat, you will get the constant pressure distribution. These two things you have to understand. Sometimes they will give flow over the flat plate. They won't tell whether it is subsonic or supersonic, but the above derivation what we derived, it is for both applicable for subsonic and supersonic, so you no need to worry. But again, if you want to understand, by seeing the pressure distribution you can understand whether it is subsonic or supersonic. Is that clear? Variable means subsonic, if it is constant then it is supersonic. In the supersonic, additionally you will get the waves. Okay, this is shock wave, oblique shock, and this is expansion fan, this is oblique shock, this is expansion fan. So all these things you will study in aerodynamics too. Okay, for different object, how the different shocks are formed, how to find the properties, etc. and all you will study in aerodynamics too. Okay, this is general. Now we will go to the problem. So in the first problem, so they have taken one thin flat plate with a chord of 1 meter and angle of attack 10 degree, and they are given upper pressure, lower pressure, and you can see the pressure which has the x term. That means along this x direction the pressure is varying. Okay, that means this is subsonic flow. Okay, so the pressure term has the x in its equation. That means the pressure is varying along the x direction. Instead, if they are given, for example, 1000, here it is 2000, like that, in a single value if they are given, then it is constant. That means supersonic. Okay, so here the pressure is variable, shear stress also variable, along the x direction it is various. So using this pressure and shear stress, we have to find L and D. Okay, so L and D equation, we know that always first you have to find normal force, axial force before finding the lift and drag. To find the normal force, axial force, we need this pressure and shear stress. Actually, this is the final equation, we are going to use it. Okay, we are going to substitute pressure here, we are going to find normal force, we are going to substitute shear stress here. Using that, you are going to find the axial force, then substitute here, you will get lift and drag. I will tell you how to get this equation now. Is that clear, the procedure? This problem you understood, right? So here, okay, so here they are given pressure on the upper lower surface, shear stress on the upper and lower surface. Both term has the x, that means it is variable along the x direction. So this is in the subsonic flow. So what they are asking is, we have to find lift and drag force. Okay, we know the lift and drag force, which is in terms of normal force and axial force. So we have to find this normal and axial in terms of pressure and shear stress. So this is the final equation. This we didn't derive. The next step only I am going to tell how to derive this equation. So once we derive this, straight away you can substitute pressure in this term, shear stress in this term, so that you can get the normal force, axial force. Substitute here, you will get lift and drag. That's the overall procedure. Now I will explain how to get these two equations. Is it clear? So you know pressure will act normal to the surface. So this is PU, this is PL, and shear stress will act tangent to the surface. So this is tau U, this is tau L. It is given from these four. We are going to find this n dash a dash. Then we are going to find L dash d dash. Is it clear now?
Yes, sir.
Okay. So lift drag already we derived. Now we will see how to simplify this n dash a dash. So this already we checked it, right? This is for a thin aerofoil we derived. Okay, this n dash a dash. That one we are going to convert it for the thin flat plate. So this is the flat plate at an angle of attack 10 degree. You know this is the lift direction, this is the drag direction, okay, and this is the normal force direction, this is the axial force direction, okay, and you know pressure will act tangent to the surface. Sorry, pressure will act normal to the surface. So first time I am using my tablet in this PC, so the driver is not working properly. Okay, so pressure is normal to the surface.
Sir,
Hmm.
sir, one request, sir. If possible, can you keep the ink annotation so that when you upload the PDF, we can refer to those ink annotation? Because in last few PDFs, there weren't any of those.
Actually, that PDF is not for what is that? That you cannot refer for the exam point of view. I will upload my notes. Whatever I teach in the same form with all explanation, I will upload my notes. Okay, that you can refer.
Okay, sir. Okay,
Okay,
okay. Thank you, sir.
350 is just to teaching only, but just additionally I am uploading it. That's it. I will upload my notes.
Okay,
Hmm?
okay. Sure,
So
sir.
once I cover this problem and all, maybe I will upload it. Okay. Because in this form you cannot write in the exam, right? There should be some in between lines, etc. and all explanation. That I will upload it in with my notes. Okay. So where did I stop? Okay. So pressure act normal to the surface, shear stress act tangent to the surface, and this is the general equation, normal force equation in terms of pressure and shear stress. You can see if it is a flat plate and the theta is constant, right? Okay. So that is the first term, and additionally this theta, if you see, it is measured between pressure and the normal stress, normal force. For example, here you can see this is the normal force direction, this is axial force direction, and this theta we have taken, it is angle between the pressure and this the normal force direction. But see here, this is the normal force direction, right, which is tangent to the chord line. So both normal force and pressure both are in the same line. That means theta is 0 degree. Okay, see here, shear stress and axial both are in the same line, that means 0 degree. So if theta is 0, then cos theta will be 1, sin theta will be 0. So this time we can cancel. So that actually this is for thin aerofoil, that we can convert to the flat plate. Okay, only we will get PL minus PU into ds. Instead they mention here it is x. They would have taken s, but here they mention different notation s x. So instead of dx I am using ds, I am using dx. Is that clear? I will repeat. So this equation we derived it for the thin aerofoil, okay, and this theta, it is the angle between normal force direction and this pressure, or axial force direction and the shear stress. Here if you see pressure and axial normal force in the same direction, that means theta is 0. Okay, here also the theta is 0. So you have to substitute theta is 0. In that case you will get 1 here, you will get 0 here. So that means this term is get cancelled. You will get only PL minus PU into ds. But in the problem they have mentioned along the plate the variable is x. Instead of s they are given x. We can use any notation. So instead of ds I am writing dx. So this is for the flat plate, this equation. Is that okay? Similarly, axial flow equation, this is for thin aerofoil. Okay, again the theta is 0. So here this time is 0, this time is 1. You will get A dash is equal to tau u plus tau L ds. Instead of ds we have dx. That's how we are getting this two equation for the flat plate. Is it clear?
Yes, sir.
Okay. So that means here if you go, so this is for thick aerofoil, this is for thin aerofoil. Then for the flat plate, it should be PL minus PU into ds. Okay, and this is for thick aerofoil, this is for thin aerofoil, and for the flat plate, it will be A dash is equal to integral tau u plus tau L ds. Okay, each problem they may give this as s or x. They will use different notation. That's it. This is clear, right? Thick aerofoil, thin aerofoil, flat plate. Shall we proceed further?
Yes.
Yes, sir.
Okay. So here we know the PU, PL, tau u, tau L. So straight away we have to substitute here. Okay. So first I am finding n dash. So we know PL, PU. This is PL, this is PU. Substitute. Okay. PL minus PU. You will get this term. Okay. Then we have to integrate it. Before that, this x minus 1 whole square we can expand. Okay. A minus b whole square. Then if you integrate, you will get x cube by 3 minus 2x square by 2, 2 to get cancelled, plus x. Here additionally one x term, that's it. Then apply the limit, you will get this n dash value. Is that clear? So we found the n dash for flat plate, and we know the PL and PU value. Straight away substitute, subtract, and this x minus 1 whole square you expand, then integrate, substitute the limits, this normal mathematical procedures, you will get n dash value. Any doubt here?
Yes.
Same way, A dash. Okay, this is the formula. We know tau u, tau L, substitute, then add, then x power 0.2 you have to integrate. Okay, that means if you do, if you will get x power n plus 1 divided by n plus 1, then simplify, then apply the limit, you will get A dash is equal to 1274 Newton. Okay, if you integrate, you will get, I think, x power 0.8 divided by 0.8, right? X power n plus 1 divided by n plus 1. Then substitute x value. Okay, you will get this A dash. So once you know the n dash and A dash, substitute here, and we know angle of attack is 10 degree. You will get lift, also drag. And now we are going to discuss the supersonic flow over the flat plate. That is, the given Mach number is 2 and angle of attack is 10 degree. As I told, if we keep this flat plate in a supersonic flow, there will be a shock waves. Okay, so here there will be expansion fan, here there will be oblique shock. These things you will study in aerodynamics too. The reverse will happen here, and the pressure distribution will be constant throughout the flat plate. So that's why they are given constant pressure value. Okay, and the normal SI unit, you know, right, Newton per meter square, and this is the British unit. Instead of Newton, they are used pound, and instead of meter square, they used feet square. Okay, this is SI unit, this is British unit. Okay, so actually in the exam we will use only SI unit. We won't use this British unit. But if you check any foreign author books, mostly all the units will be given in this British. So I'm just introducing here. So So pressure is constant because the flow is supersonic, but shear stress will vary because along the direction the friction will increase. So shear stress will vary along the distance. That's why there is a S term. So here they taken distance along the flat plate is S. So here we have the S. Previous problem I think we have taken X. So here also we have X term. Here they just change the notation. Okay, so yes, yes. Again, formula is same. LD formula, N formula, A formula. Simply you have to substitute and apply the limit. So first, if you take the pressure, so both terms are constant. Okay. So PL is 1132 lb per feet square. So PU. So PL is 3 phase 6 side. So this constant term, if you take it outside, and this is the remaining term, and if you integral, you'll get only S. And this is our final formula. Substitute directly P value, then S value. So S it is given. Okay, the length is 3 feet. So finally we are getting N dash in terms of LB. Okay, so instead of Newton, we are getting in LB, pound force. Is that clear? So it's not necessary that you have to go for the integration method. If you find that values are constant, straight away you can find force into distance. And that is pressure into distance. This area, pressure into area. The difference will give you the force acting in this plane. Okay. But shear stress, if you take, it is equal on upper and lower surface, but it is not constant, it is variable. So you have to go for integral. So both are equal. So I am writing as 2 integral tau ds and substitute the tau value, integrate, you will get this value. Then you know normal L and D equation. Alpha they mentioned 10 degree, substitute, you will get L dash and D dash. Is it clear? Compared to the previous problem, this is very easy because there is no integration for the pressure, it is constant. Okay, only for shear stress you have to integrate it. Is that clear? So only these 4 formulas are different. All other substitution, integration, applying the limit, everything that you studied in your mathematics. Okay, only if you remember these 4 formulas, you can get the 12 marks. Is that clear? Or should I repeat?
Yes, sir.
Okay. The next problem. So instead of flat plate, here they are given the wedge model. Okay. So again, it is in supersonic flow, Mach number 2, and angle of attack is 0, and half wedge angle is 5 degree, and this chord length is 2 meter. Okay, chord length always will measure from leading edge to trailing edge. Here this is the trailing edge. Okay, this line. So the chord length is 2 meter, and we know the pressure will be constant on the upper surface and lower surface. And here additionally they mention there is a free stream atmospheric pressure acting on this rear face. Okay, so Mach number is 2, angle of attack is 0. So because of supersonic flow, there is a shock wave pattern. So half wedge angle is 5 degree, chord is 2 meter, upper and lower surface, the distribution will be constant, and back side the atmospheric pressure is acting. This is the problem. And they mentioned the model is in the sea level condition. So this atmospheric value we can take it as 1.0 10 power 5 Newton per meter square. This is 1.225. Like that, temperature, everything you can consider. Sea level condition. Mach number alpha, C the event. So as it is at 0 degree angle of attack, you will get similar type of, so about this axis, everything will be symmetry. Okay, similar type of flow pattern. Okay, similar type of wave pattern. So same pressure distribution, everything will be there as it is a symmetrical object. So if the pressure difference is same, then lift also will be 0 for this object. Okay, always for symmetrical object at an 0 degree angle of attack, lift will be 0. Only drag will be there. That's why in this problem they are asking coefficient of drag. Is it clear? Okay, they may give flat plate, or they may give diamond aerofoil, or they may give wedge model. Okay, any model they give, if it is symmetry about the flow direction, that is angle of attack is 0, the lift will be 0, because flow pattern will be same on both sides, pressure distribution also same on both sides, and there is no net pressure difference, so lift will be always 0. Is that clear? So sometime here they ask directly find CD. If they ask find the force coefficient lift and drag, then straight away you can write angle of attack is 0, the object is symmetry, so net pressure difference is 0, so lift is 0, C also 0. Like that, first you can answer. Then you have to find the CD. Okay. Some people will forget. They will try to find the lift value by substituting in these equations. If you substitute also, you will get the same 0 value only, but there straight away you can write it. Is that clear? Should I repeat anything?
Yes, sir.
Okay. So as it is a flat surface, so pressure distribution is constant. So Pu is equal to PL because 0 degree angle of attack, it is symmetry. So it is constant. Only shear stress varies along the distance S. Okay. So this length varies along the S. Okay. Now we know the formula. N dash, A dash, L dash, D dash, everything. So we can find the D dash, then we can find the CD. Okay. Before that, let's find the area. So they mentioned chord is 2 meter and this half edge angle is 5 degree, and we know pressure act on this surface. Okay. So we should know the length of this line. Okay. So you know normal right angle triangle thing. So how to find it? This is 5 degree, this is 2 meter, here 90 degree, this length you have to find it, this S2 you have to find it. I think S2 cos 5 degree is equal to 2 meter, right? Am I correct? So S2 cos 5 degree is 2 meter, S2 sin 5 degree is this distance, that is S1 by 2, the whole distance is S1, then you can take only this as S1 by 2. Okay. Sorry, it should be then S1 by 2, right? Okay. So from this, if you rearrange, you can get S1 by 2 and S2 value, the normal trigonometry thing only. In that case, if you find S2 is 2.0071 and this S1 by 2 is 0.1749, then for complete S1 multiply, you will get S1 value. If we are finding this S2 S1 means we are going to find the forces. So to find the force, we should know the pressure and the area acting. Okay, pressure and the area should be known. This pressure is acting on this length. That's why we are finding this S2 and S1. Okay. So what we need is the drag force. So directly I'm writing the drag equation, and we know angle of attack is 0. So sin 0 is 0, cos 0 is 1. Then you will get D dash is equal to A dash. And the A dash equation also already we know that. Okay. For the thin object. So we know PL, PU, tau U, tau L and all. Substitute here. You will get D dash. Then using this equation, you can find the CD. Okay. Drag divided by half rho V squared C. Actually, this is area. The object is 2D. Okay. We are taking only chord. This is equal to span into chord. For 2D means this is equal to 1. So I'm taking only C here. So T dash is equal to A dash, and this is the A dash equation. It has 2 times. First one is due to the pressure, another one is due to the shear stress. First we will find this drag due to the pressure. Okay, first we will take the pressure component and see this is the pressure distribution, this one. Okay, so the pressure is constant, so we no need to go for the integration. Straight away we can multiply pressure into area. Okay, and we know the theta pi dD, and this is the pressure acting direction. Okay, and the formula, theta is measured between the pressure and n dash direction. Similarly, in the lower surface, this is the pressure direction. So we measure the theta. So now from here infinity is acting. It is in the same direction of A dash. So these are all the pressure distribution on three surfaces. Positive. The same way is speaking, I was speaking now.
Also, no.
What happened? I'm hearing some music and all. Okay. So now I'm finding, okay, A dash or D dash due to the pressure. So what you have to do, all these three pressure component we have to resolve in this A direction. Okay. So if you resolve, this one will be like Pu sin theta, right? Because this is theta. Horizontally we are solving. So it will be Pu sin theta component, and in the area is S2. Okay, the force is Pu sin theta into S2, and this is positive direction only. Okay, similarly this one if you resolve horizontally, it will be PL sin theta pressure into area is S2. This is also positive, and this pressure if you take, it is in the opposite direction, and already it is aligned with the A, so no need to resolve it. So it is simply minus P infinity into S1. These are all the three components. Is that clear? So Pu sin theta S2, PL sin theta S2 minus P infinity S1. Okay. So this Pu, PL, P infinity, I am resolving in this A direction. This inclination is theta. That's it. Okay. I am resolving horizontally. So we are getting this equation, and as the angle of attack is 0, both sides you will get the same pressure. So instead of these two component, I can write 2 P sin theta S2 minus P infinity S1. You know the Pu value. Okay, and sin theta is 5, S2 value, P infinity is known, S1 also known. Substitute, you will get drag due to the pressure. Is that clear? Or should I repeat? So first step, we have to find these areas where the pressure is acting. Second step, finding the equations. So we have to find CD. So first drag equation, alpha is 0, so drag is equal to axial force, and this is axial force, the formula in terms of pressure and shear stress. So first I am finding force due to the pressure. Okay, as it is constant, straight away we can resolve all these three components in the A direction. That's it. Now we can go for the shear stress component. Shear stress is mentioned. Again, both are equal. 431 s power minus 0.2. Okay, so this is the shear stress equation. As both are equal, we can write 2 integral tau cos theta ds, and we know the tau value 431 s power minus 2, and theta is 5 degree. Again, normal integration and apply the limit, you will get drag due to shear stress. And for the complete overall drag, you have to add drag due to pressure plus drag due to shear stress. This is the total drag value of this wedge model. Okay, so we found drag due to pressure 10512, drag due to shear stress 1873. Add both things, you will get the total drag. So once you know the drag, you can find the CD. Okay, drag divided by half rho v squared c. Chord is given, it is 2 meter. Okay, and density, sea level density is mentioned, it is 1.225. Okay, and drag, just now we found it. Only velocity we have to find it. But what they are given is Mach number 2, and we know the relation between Mach number and velocity. So Mach number is equal to v by a. So m is equal to v by a. If we need the v, so rearrange, it will be m into a. So Mach number value we know it is 2, and a is speed of sound. And this formula you studied, right, in thermodynamics. A is equal to root of gamma RT, speed of sound equation. I studied this. A is equal to root of gamma RT. So you should have studied this in thermodynamics. But again, in area 2 also, we have the derivation, how to derive it. Okay, that time also we will derive it once again. So this gamma is the specific heat 1.4, and R is gas constant 287, and sea level temperature 288 I have taken. So the velocity is 680. Okay, so now substitute drag value and half rho v square into the c value 2. You'll get CD is 0.022.